All right, what is the value of x? Well, in order to find the value of x, we're going to compare this line segment 4x to this line segment 3x plus 4. Okay, and so the question is, how do I compare them? Well, they're equal to each other. Okay, so to find the value of x, we're going to take 4x, we're going to make it equal to 3x plus 4, and then we're going to solve this for x by subtracting 3x's from both sides. That would give me x is equal to 4. So in 8b, we know that x is equal to 4. Letter C, find a to b. Well, a to b is represented by 4x. You can see right here, a to b. X we just found out is 4. So substituting 4 for x, we get a to b is equal to 4 times 4. That is 16. Find b to c. B to c is represented by 3x plus 4. But we just found out that x was 4, so we're going to substitute 4 in the place of x. So that means b to c is 3 times 4, 12 plus 4, so that is also 16. And notice the two values of a to b and b to c are equal, which is what we said they were when we found the value of x. Okay, moving on to number 9. From the information given in the figure, how is TV? So we're related to line segment SU. So how is TV related to SU? Well, you can see TV intersects SU right here at R, and we have a 90-degree angle, so that makes it perpendicular. But then SU has been split up into two equal parts. So that means TV is a perpendicular bisector. Okay? How do I know it's perpendicular? Because of the 90-degree angle. How do I know it's a bisector? Because of the congruent tick marks. Okay? So now we're going to find T to S. So we want to find T to S. Well, if you notice, T to S is the exact same as T to U. T to U is 3.7, T to S is 3.7. Next one, let's find U to V. Well, if you notice, when I look at U to V is right here, which is what we don't know, but U to V is exactly the same as S to V, which is 7.9. So U to V has to be 7.9 as well. And then the fourth one, D, find S to U. Well, if you notice, S to U is all the way across the shape, but that tick mark and that tick mark are the same, and you can see there's a 3 for R to U. So if R to U is 3, R to S, which is equal to it, is 3, which makes S to U 3 plus 3. So S to U is going to be 6. And I got it by adding up 3 and 3. Okay, number 10. All right, so here it says MO. So here's line segment MO right here. And it says, is the perpendicular of blank. So MO is the perpendicular bisector of line segment NP. Okay, how do I know that? Well, the 90-degree angle, right where NP and MO intersect, and then you can see NP has been split into two equal pieces, so it's been bisected. Find M to P. Okay, so let's get out the highlighter. Highlight M to P. M to P is right here. What is the same as M to P? That would be M to N, so M to P is 4.5. Okay, C, find NO. Get out the highlighter. Highlight N to O. So you can see N to O is right here. So what in the picture is congruent to N to O? Well, that would be P to O, which is 9.5. So N to O has to be 9.5. Okay, the last one, find N to P. So N to P, if you notice, is this entire length of that segment. Well, these two lengths are equal, and that length is 3.2, so that means that has to be 3.2. So N to P is going to be 3.2 plus 3.2, 6.4. Okay, so there we go. Moving on to the back side, numbers 11 through 15. Okay, number 11. Here we have our picture that we're using in number 11. Notice, we have a line segment E to G. We have a 90-degree angle. Right where E to G intersects line segment H to F, we have 90 degrees. That makes it perpendicular. Okay, and then we have these equal tick marks, which means that H to F has been split into two equal pieces. So that means G is the midpoint. So that means that E to G, line segment E to G, is the perpendicular bisector of segment HF. Okay, well, how do we know that? Well, because E to G made a 90-degree angle with HF, and E to G split HF into two equal pieces. So what are the length of EF and EH? So let's find EF right here. So you can see that we have E to F is marked as 8. So that means what's the length of E to H? That would be 8 as well. So there we have that answer. They are both 8. Okay, then we have find the value of Y. Well, you can see right here, we have a 2y plus 18 representing this angle right here. We have a 4y representing this angle right here. Well, those two angles, when I compare them to each other, they're the same measurement. Therefore, to solve for y, I take the 4y angle, I set it equal to the 2y plus 18 angle, and then I use algebra by subtracting 2y from each side to get 2y equals 18, and then I divide both sides by 2, so I get y to be equal to 9. Okay, so how did I know that those two angles were equal? Well, remember the two triangles here are equal, which means all of their corresponding parts that match up have to be equal. Part D, find the measure of angle GEH. So where is GEH at? Start at G, follow it up to E, take a turn for H, so it's that angle right there, which is represented by 2y plus 18. So GEH is represented by 2y plus 18. We just found that y was equal to 9, so I'm going to substitute a 9 in here. So 2 times 9 plus 18 gives me angle GEH is equal to 36. Okay, the next part, find the measure of angle GEF. So where is angle GEF at? So there's G, follow it up to E, take a turn for F. Well, it's that angle right there, which is represented by 4y. Okay, once again, we just found y to be 9, substituting 9 in for y, we get angle GEF to also be 36, which, notice, their measurements are the same. So 36 degrees and 36 degrees, which is what I expected because I said the two angles were equal to each other. Number 12, make a two-column proof. Okay, so let's write the given first. Remember, the first statement that we write is always the given. So we know that line CP is a perpendicular, that's the symbol for perpendicular, we went over this in class. It is a perpendicular bisector of segment AB. Okay, so my first statement is going to be given. All right, now let's go through this proof. So remember, whenever we're doing a proof, we always want to start and see, are there any pre-marked marks that we know are equal? And if you notice right here, we are told that this angle is 90 degrees. Okay, so that means that the angle right next to it has to be 90 degrees. All right, so I'm going to put a 1 here and indicate that as angle 1. I'm going to put a 2 here, and I'm going to indicate that as angle 2. And I'm going to say that angle 1 is congruent to angle 2. Okay, and the reason why they are congruent is because of, how did I know that they were both 90? I knew that because perpendicular. So I used the definition of perpendicular. Remember, what does perpendicular tell me? If CP is perpendicular, CP is perpendicular with AB, it means you have to have 90-degree angles. 90-degree angles are equal. Okay, the third thing, notice it also says CP is a bisector of AB. So what does that mean? It means that AB got split into two equal pieces, and those have to be the two equal pieces. So we know that A to P has to be congruent to B to P. Okay, and what's the reason for that? We are using the definition of bisector. Okay, bisector, remember, splits something into two equal pieces. Okay, now the fourth step is, I want to prove that A to C is congruent to B to C. But remember, I can't tell if A to C and B to C are congruent until I know that the triangles are congruent. So my fourth step is I need to find a third part that's congruent to show the triangles are congruent, and you should notice that it's right here. So line C to P, or segment C to P, is congruent to C to P. That segment is equal to itself in both triangles. That is called the reflexive property. Okay, and now you can see I have enough information to say that triangle APC is congruent to triangle BPC. And my reason for that would be I have a side, an angle, and a side that are equal in both triangles, and the angle is in between the two sides. Okay, so now since the triangles are congruent, that allows me to now say that A to C is congruent to B to C. Even though A to C and B to C don't have any tick marks on them, they have to be congruent because the triangles are congruent, and that's what we call Cpctc, which is a very shortened way for saying that if the two triangles are congruent, the parts that correspond with each other have to be congruent even though they don't have any tick marks on them. So that would be your proof of number 12. Number 13, find the circumcenter of the triangle. Okay, so I'm going to zoom this one in. And for this one, I'm going to use colors to help you out. I'm going to use markers, okay? So we want to find the circumcenter. So how do you find the circumcenter of a triangle? Remember, the circumcenter, if you forgot, it is the point where the three perpendicular bisectors meet. Okay? So we want to draw the three perpendicular bisectors. So we want to draw a perpendicular bisector with the bottom side of the triangle. So how do we do that? We put a point right in the middle, because that's going to indicate that it's going to bisect, and then we draw a line segment going so it's perpendicular. Okay, so that green line segment would be a perpendicular bisector of the bottom part of the triangle. Those two parts are equal. Now I'm going to use my yellow highlighter to draw a line segment that's a perpendicular bisector with this side here. So we go to the middle, we put a point, put the tick marks to show that it's right in the middle, and then I'm going to use my ruler and I'm going to draw a perpendicular line going right through the middle. Okay, and you'll notice that line goes like that. Okay, and then I'm going to do the same thing with my red pen in this third side right here. So I'm going to go right to the middle of this third side, which is right here. I'm going to put tick marks to show that it's in the middle. And then I'm going to use my ruler to draw a perpendicular line segment going right through like that. So where the green line, the yellow line segment, and the red line segment meet, those three are all perpendicular lines. I should have put 90 degrees where each one of them crossed, so I know that I had them. That point right there, boom, right there is called the circumcenter. Okay, so it said find it. Well, we found it. It's right there. What are its coordinates? 1, 2, negative 2, 2. So the circumcenter would have coordinates of negative 2, positive 2. Number 14, where should the farmer place the hay bale so that it is equidistant from the three gates? Okay, well notice the three gates are the corners. So what we are doing is we are looking for a point that is equidistant. In other words, the same distance to all 3 points. So what is that point? Well, that's the circumcenter. Remember, we said in class, the circumcenter is the point that is the same distance to all 3 corners of a triangle. Okay, so how do you make a circumcenter? Well, once again, I make perpendicular bisectors. So I'm going to go down to this bottom shape side. I'm going to put a point right in the middle. I'm going to put tick marks to show that it's in the middle. And then I'm going to use my ruler to draw a perpendicular line segment that goes through the middle right there. Like that. Okay. Then I'm going to do the same with this side right here. This side right here. So I'm going to find the middle. The middle is right there. Okay, I'm going to put tick marks to show that it's right in the middle. And then I'm going to use my ruler and I'm going to draw a line segment that goes right through the midpoint so that it turns out that it's perpendicular with that side right there. And you can see that it looks like that would be perpendicular right there. Okay, and then I'm going to do the third over here. So I'm going to go right to the middle of that third side. Put the tick marks in to show that that third side's in the middle, and then I'm going to use my ruler to draw the line segment that goes right through the middle and is perpendicular. So I have a 90-degree angle, it's in the middle, perpendicular bisector. This green line segment, I have a 90-degree angle, it's in the middle, perpendicular line segment. The yellow line segment, it's in the middle, it's perpendicular, 90 degrees, line segment. Right there is my circumcenter, so that point is the same distance to all three gates. Where is that point? 0, 1. So the farmer should place the hay bale right at the coordinates 0, 1, and then it will be equidistant, the same distance to all three gates. Okay? Number 15, where should the fire station be placed so that it is equidistant from the grocery store, the hospital, and the police station? So same concept. Notice the police station is a corner of the triangle. It's a vertice. So is the hospital. So is the grocery store. And I want to place the fire station somewhere in here, but I want the fire station to be the same distance, to be equidistant from all three corners, all three vertices. So how do I do that? Well, I create a circumcenter. Okay, so let's create a circumcenter. Let's create a perpendicular bisector between the police station and the hospital. So where's the middle between the police station and the hospital? It's right there. Okay? So then I draw a line segment that's going to go right through the midpoint, but it has to be perpendicular, so that would be the line segment right there. Okay, then I'm going to go down to the bottom side between the hospital and the grocery store. I'm going to put a point right in the middle, so there's 1, 2, 3, 4, 5, 6, so that means 1, 2, 3 is right in the middle. So that point right there is in the middle. And then I'm going to draw a perpendicular line going right through the midpoint of the bottom side of the triangle, which is right like that. Okay, and then I'm going to do the same with the third side between the police station and the grocery store. So the middle is right there between those, so I'm going to put congruent tick marks, and then I'm going to draw a line segment that goes right through the middle and then makes that as perpendicular with the third side of the triangle, and that would be that line segment right there. So you could see we have 90-degree angles, so those are perpendicular. We have 90-degree angles and we have 90-degree angles. So that point right there, boom, that is my circumcenter. That's where the fire station should go. So what are the coordinates of that fire station right there? It's a little hard to tell because I got all sorts of craziness going on. But that's the origin right there. So it's over 1, up 1. So the fire station should go at coordinates 1, 1. All right, there you go. Practice with perpendicular bisectors, circumcenters, and so on.